This is an introduction to Chapter 15. In Chapter 15, we're looking at impulse and momentum. The impulse-momentum relationship can be derived from Newton's second law. We start with Newton's second law here. We have the sum of the forces is equal to the mass times the acceleration. You can rewrite the acceleration as the derivative of velocity with respect to time. Then if you bring the dt over to the left-hand side and take the integral of both sides, you have the impulse on the left-hand side here. This is the sum of the net force with respect to dt, giving you the impulse. On the right-hand side, you have the mass times the integral of dv. If you do that integral, you get the mass times the velocity 2 minus mass times velocity 1. This is the change in momentum. The impulse-momentum relationship is useful in cases where the impulse is 0, the change in momentum is 0. If you have a net force acting on your system, this is your system here. If you have a net force acting on the system, then you have an impulse, which is not 0, and the momentum changes. If you have, let's say, object 1 and object 2 within your system, and they are exerting forces on each other, by Newton's third law, these forces would be equal in magnitude and opposite in direction. So the forces which are internal to the system would cancel out if you calculated the impulse. And if there are no forces acting on the system, the impulse is 0. So the momentum of the system does not change. You should read through section 15.1 and 15.2 and do that on your own, and then we'll be ready to do some example problems.